Hi class, it's Mr. Trez, and this video is going to be about solving quadratic equations using the square root property. Our learning objective: the student will be able to solve quadratic equations by using the square root property strategy. The objective will be met if the student receives a 100% on their Google Slides assignment. Our essential question: explain how the square root property strategy allows you to solve quadratic equations. So we have already learned one strategy to solve a quadratic equation, and that strategy was by graphing. Now the key is to identify and find the x-intercepts of the related graph. So the x-intercept is the point where our parabola crosses the x-axis. It's also called the roots, the zeros, and it's our solutions. So if I take a look at our orange parabola, here we can see there is no x-intercept. So no x-intercept, no solution. If we look at our black parabola, it has one solution, which is at -4. And then finally our purple parabola has two solutions, one at -5 and one at +2. So now we want to start solving quadratic equations algebraically. One way to do it is by using the square root property. So let's look at our key concepts. A quadratic equation in the form of x squared equals n can be solved by using the square root property. The equation can be solved by applying the square root to each side of the equation. To solve a quadratic equation in the form x squared equals n, we want to take the square root of each side of the equation. So for example, x squared equals 25. So then x is equal to positive or negative square root of 25, which equals positive or negative square root of 5. So if we had the square root of 25, one answer could be positive 5, because 5 times 5 is equal to 25. Another could be -5, because -5 times -5 equals positive 25. If we have a perfect square, we're going to have an exact answer. If it's not a perfect square, we're going to need to approximate the square root. Okay, so let's just take a quick example of square roots. So let's say I had the square root of 16. So x squared is equal to 16. So what I'm going to want to do is take the square root of each side. The square root of x squared and the square root of 16. Well, the square root of x squared is just going to be x. And that's because x times x equals x squared. Now the square root of 16, so we know positive 4 times positive 4 equals 16. And then also -4 times -4 equals positive 16. So our answer, the way we write it or notate it, is positive or negative 4. Okay, so let's take a look at an example of a quadratic equation. And we want to solve this using our square root property. So our first example we have is x minus 3 squared equals 64. So we're going to apply our square root property by taking the square root of each side of our equation. So on the left side, x minus 3 squared, the square root of that is just going to be x minus 3. Now the square root of 64, this is a perfect square. So we have 8 times 8 equals 64. And also -8 times -8 equals positive 64. So our answer could be positive or negative 8. So now we want to use our inverse operation to get our solution. So instead of -3, we're going to add 3 to both sides. Now we have the x isolated, and now we're going to solve for the right side. So the number that we used for our inverse operation, that's going to go first. So we have 3, positive or negative 8. Okay, so now this is going to have two solutions. So the first solution we have is using the plus. So x is going to be equal to 3 plus 8. And we know 3 plus 8 is equal to 11. There's one of our solutions. Now we also have another solution, which is going to be the minus. So x equals 3 minus 8. And 3 minus 8 is negative 5. So here we have two roots, two solutions. So the solutions are positive 11 and negative 5. So this means if we graph this quadratic equation, our parabola would have x-intercepts at positive 11 and negative 5. And there is our solution. Okay, so let's take a look at another example. So here we have y plus 5 squared plus 7 equals 28. So our first step in this case is we want to subtract 7 to both sides. We want to get this y plus 5 squared isolated so we can use our square root property. So let's just subtract 7 to both sides. And now we have y plus 5 squared equals 28 minus 7 is 21. Now we're going to take the square root of both sides. The square root of y plus 5 squared is just going to be y plus 5. But now the square root of 21, this is not a perfect square. So you can use your calculator to find it, and we're going to round our answers to the nearest hundredths. So in this case, it's going to be 4 and 58 hundredths. And remember, we're going to write it as positive 4 and 58 hundredths, and it could also be negative 4 and 58 hundredths. So now this example is going to have two solutions. So we want to subtract 5 to both sides. So now one of our solutions is going to be y is equal to, again, we put our inverse operation number first, so negative 5 plus 4 and 58 hundredths. So y is going to be equal to negative 42 hundredths. Now we're going to do with the negative, so we have y equals negative 5 minus 4 and 58 hundredths. Okay, you can always change this to addition. And y is equal to negative 9 and 58 hundredths. So here again we have two solutions. The solutions are negative 42 hundredths and negative 9 and 58 hundredths. So again, if I was to graph this, our parabola would have x-intercepts at negative 42 hundredths and negative 9 and 58 hundredths. Okay, our final example looks like 4 times m plus 1 squared is equal to 36. So let's write that out. Okay, so the first thing I want to do is I want to take the square roots of both sides. So now, look at your terms. The square root of 4 is equal to 2, and the square root of m plus 1 squared is m plus 1. And that's going to be equal to the square root of 36, which could be positive 6, because 6 times 6 is 36, or it could be negative 6, because negative 6 times negative 6 equals positive 36. Now in this case, we want to do a little math, and we're going to use our distributive property. So 2 times m is 2m, and then 2 times 1 is 2, and that's going to be equal to positive or negative 6. Okay, we want to use the distributive property in this example because that'll remove the parentheses. So now we're going to subtract 2 to both sides, and we're left with 2m is equal to negative 2 plus or minus positive 6. Okay, so now in this case we have 2m is equal to negative 2 plus 6. And let's just simplify this one. So 2m is equal to negative 2 plus 6 is equal to positive 4. Let's divide 2 on each side. So m is equal to positive 2. So one of our solutions is m is equal to 2. One of our solutions or roots is 2. So now let's do the other. So we have 2m is equal to negative 2, then minus positive 6. So this becomes 2m is equal to negative 2 minus 6 becomes negative 8. Let's divide each side by 2. And 1m is equal to negative 4. And there are our two solutions. So our solutions are 2 and negative 4. And again, what does this mean? Well, if I graphed this quadratic equation, I would have x-intercepts at both 2 and negative 4. Thank you for watching this video. If you have any questions, please send me an email.